All right, y'all didn't hear me. So I'm just gonna start over real quick. So this is a Rover meeting, March 31st, 2022, where we will be discussing a small Arduino workshop, basically going over microcontrollers, how to work with, what's up, Jesse? How to work with different sensors and different motors. And then after that, we will be shortly discussing how we're going to be approaching making the joystick, the wired joystick controller for our Rover. So yeah, I can take it away. Ross Sample, electrical engineering lead, and Jonathan Kamer, computer science lead, will be covering the topic of the Arduino workshop today. So.
All right. Let's see. Why is your mouse so
slow? I tried
slow?
to present it, but I didn't see like the presentation button on that one.
Bottom right hand side.
Is that like the slideshow?
Oh, I don't know. So
Does that count?
I guess so.
Okay. Go for it. Yeah, see, it does it by itself, doesn't it? Is it transition?
No, I did that.
Okay, cool. Take it away.
All right. So today's workshop is just pretty much just from start to finish how if you were going to do a Arduino workshop, like if you were going to try to do something with an Arduino at home, what would you be doing? Entirely independent of like if we were giving you the information or just anything like that. So this is pretty much so you can be independent rather than having to like require us or anyone's input. So just learn how to interface the board with your computer. And then like whatever hardware or like peripheral or sensor you're going to choose, and then just like look for a walkthrough online and then check the code, make sure the code's running, download the libraries for it, and then breadboard the diagram, and then put it all together and just make sure that it works. So what we have, I just put all of these like either links. I mean, the yellow is actual just links to walkthrough to them. And then the ones I didn't like the walkthroughs, I just put some of the code and stuff further down. But so setup is going to be just plug in the Arduino board firstly, and then if it doesn't automatically show up in the Arduino IDE, you're going to want to go to your device manager. And then if it's a knockoff board, which are extremely common nowadays, you're likely going to have to go look for a third-party software to allow your computer to recognize it. So,
do you have an example of what Arduino board, knockoff board looks like? Or not knockoff board, but, you know, like the board that you might use?
They generally, I mean, it looks the same.
Yeah, it's gonna look. Yeah, I mean, it's gonna look almost exactly the same. It's just gonna say the name of it. Yeah, just.
It looks like.
Yeah. There we go. Yeah, I mean, it's just gonna say a different name. So like this one is Geekcrete, and when your computer doesn't recognize it, you're just gonna look up that board, and then you'll likely get sent to where you're gonna need to download the driver for it.
And this will be online or on Arduino IDE?
That'll be online because they use different like drivers. So for like that board, if you plug it in, your computer's not going to recognize it as an Arduino. You're going to have to go find whatever driver that you're going to need for that. Download the driver, then the Arduino IDE, and that's like an Uno.
It is Uno?
Yeah.
We're working on the Uno or the
We're going to be working with the Nano.
Nanos are bigger or smaller? They're bigger than this.
So Nano. Uno.
Let's demonstrate that.
Yeah.
All right, so we got, yeah, just, I guess, show it to the screen.
All right, so from smallest to biggest, this is going to be the Nano. This is going to be the Uno equivalent knockoff. And then this is going to be the Mega. So,
Oh, are y'all part of the Rover or the Art?
they're doing.
Arduino workshop? Oh, yeah, yeah. Just sit anywhere while we wait. We just started, so.
Yeah.
And also, if y'all have access to the Discord, I placed an attendance sheet there. If y'all want to sign in, please make sure that we got.
I guess I take a step back.
Yeah, you can take a step back.
Yeah.
We can go over stuff that we just went over today. So, sorry, I don't believe it. Alex?
And if you want to actually do something with them, you can.
We got the.
Yeah, so I mean, we have everything to actually run them on the computer and do all that. And we can walk you through it.
Oh, I'm Jonathan. Yes, so that's Jonathan Kiemer, computer science lead, Ross Sample, electrical engineering lead, Aaron, and then project.
Yeah. So what we were going over is just like the entirety of what we're doing. Like this is a walkthrough. So if you wanted to like at home and you were like, hey, I want to make a motion sense light for my like porch, you could, this walkthrough is just telling you all of what you're going to need to do and probably the most common steps you're going to run into doing it and how to overcome those. So learn how to interface the board, pick a peripheral or sensor, and then find an online walkthrough, which pretty much everything you're going to ever need is going to be there. And then you're going to check the code, and then there's going to be like libraries you're usually going to need, where you're going to find those libraries, how you're going to find them, and then just breadboarding and then getting it to run.
And then like your previous example was, what was that, the Geeker one?
Oh, yeah, yeah.
So if you were to get the screen, we're literally type in Geeker drive, right?
Yeah. So these are all the sensors I just like put on there, and like the yellow links are literally just gonna be like full walkthroughs. They're gonna have the wiring diagrams. They're gonna have the code. So all you're gonna need is like the hardware, and like it'll do all the other work for you. So it's a setup. So if you're gonna take these and like plug them into your computer right now, this one is gonna work splendidly. You're gonna plug it in, and your computer, the Arduino IDE will recognize it immediately. And once it recognizes it, it's going to, you're just gonna select that. But if you're gonna use an off-brand board like this Geeky or whatever, you're likely gonna run into the issue where your computer doesn't have the driver to boot it up. So you're gonna, easiest way to do it is gonna be like Google the name and then just like Google the board, and then the driver will likely come up. You're gonna download that driver, and then your computer is gonna recognize it, and then you can put it into the IDE. That is gonna be a common problem. And if you can't get the computer to recognize the board, even if it doesn't look like a knockoff, there is a good chance it still is. So first problem, if you can't get like your computer to see it, that's probably where you're going to be running into the issue. The main easiest issue. And then look for a walkthrough online, really just so like, if you want to do a DHT11 temperature and humidity sensor, or you want to do a LCD screen, you're just, all you really have to do is Google that on the Arduino. And then you're going to find a million more workshops. You're going to find them on Arduino.com. You're going to find them on YouTube. You're going to find a bajillion websites by itself. And then all of them are gonna have code, and all of them are gonna be pretty much pretty similar code. And then, yeah. And so once you get to the coding phase, that's you're gonna have like the walkthrough, and the coding block is gonna be there. So I recommend usually just copying the coding block and then dump it into Arduino, save it, and hit verify. Right there on most of these sensors and most of the LCD screens, pretty much anything you're going to be running on Arduino, right there you're going to run into an issue where things say, at the top where you include the libraries, it's going to say you don't have this library. So that's going to be, once you get into the coding part, it's probably going to be the hardest. Like, then like you literally just get that include file and you're going to go look on whatever search browser you want. Best place to look download it is going to be GitHub, because almost all of these sensors are going to just have open libraries. So the person that made those sensors is going to just have those libraries prepared on GitHub. You're going to go find them, and then you're going to want to go to wherever you save Arduino in your computer, and then go to libraries, and then all of those libraries is going to be where your actual like libraries for the Arduino is. You're going to want to save it in there and then unzip the file. And once you do that, your Arduino will be able to run. If you don't put it in that libraries folder and you don't unzip it, you'll likely run into some issues.
So Ross, with the coding phase, that's just like where the board is connected to your laptop. You don't actually, do you have to?
At this
actually-
point, I wouldn't even say you're going to be having your, like, you don't even need your board actually connected for any of this library.
Do you need, so like, it's just like the code lives somewhere? Like there's just like there's like a code base for the Rover that lives somewhere?
Yeah.
So if you don't mind me
Yeah.
going on Google, showing
Yeah.
the GitHub example, I also have Arduino IDE to
Yeah,
present to
you
the
can pull
people.
up the ID and I can specifically show it.
Cause I think that like my confidence gap is like, there's coding of the board, and then there's like the interface between the board and the actual component. And so does the component ever get like, programmed, or is it like a plug-in thing, like once it's fired up, once you happen to pin one of those pins? So like there's pins on the, yeah, and those pins correspond to the different component. And like, so when you actually are communicating between the board and the component, is it just a matter of like somehow connecting the board to the component, and then like how does that actually work?
Yeah, so, okay.
Well, basically, once you set up the code, you're just gonna hook it up through USB, and it's gonna recognize it on the IDE. But here's also, so is there any example on GitHub that you might like to show, or I could just show them like, this is where you could go if you want to look in Arduino libraries. I literally just typed in Arduino libraries on
Yeah,
Google and it popped up on GitHub.
So a good example is the GHG11 humidity and sensor.
Is there a way to import them directly through the ID? Because I thought so.
You can, I'm pretty sure you can, but you're not always going to find the libraries you need. And I was also doing, like, if you do it that way, it's going to be a little easier. But I wanted to make sure that y'all knew where, if you can download it from outside source, where you should put it in the library.
Like a third party that.
Yeah, because if you don't put it under the libraries folder, you're going to likely run into some problems. So,
And then, so let's say I downloaded something, where would I go to open up that file? Would I go to File, Open? Right there?
yeah, and then wherever you're gonna save, you can usually just copy the text block and drop it into a new Arduino file. But if you download the Arduino file, you're just gonna get it open and then open the file, and it should be there.
So if I want to,
Like, do we have like our
Yes.
PSA swap repository?
yes, so we do have a place where
Yeah,
that
for GitHub.
lives. Well, actually, I'll talk about it during our general meeting presentation.
Yeah.
So And then, yeah, did you want to get back to the slides?
Yeah, sure.
Cool.
And if y'all want any hands-on, like we have all the stuff that you could, like, if you want, I can show you, like, step for step how to do this on whatever. All right. And then, yeah, once you unzip the files and you hit verify, and like it's not kicking back any errors. There are going to be dozens of errors you can get, and they're going to be for different reasons. And really, I can't just tell you like, well, these are going to be the top 5 most common errors.
Did they usually provide any additional instructions on GitHub? Probably just follow that.
Yeah, and then really, if you Arduino is such a common board, if you get an error kicked out by the Arduino IDE and you go try to find it on, it's probably going to be Stack Overflow or even like another like a walkthrough will pop up and tell you. It's going to have a way to get through that. So you just have to be resourceful and then be willing to go look for the solutions. They're always pretty much always going to be out there. I'm not going to say always. I've done projects where I put an error out, like I've Google searched an error, and it's just like there's nothing on the internet that, and if you're just like, well, I guess I'm the first person to ever run into this. It will happen. And then you're also going to find things that don't work. So the wiring, so stuff like this one's a good one. So the wiring, a stepper motor is, it takes steps as it turns. So it's going to be, that's servo. Yeah, that is, yeah. So this is exactly actually all the exact same cables. So a stepper motor, you can control it far more specifically than a servo. Servo, you can really just go forward, backwards. You're not going to get all that much control over it. So for like a 3D printer where it's going to be moving, you're going to be using a stepper motor. It's going to be far more like for the price point.
Move this many radians or something like that.
Yeah, you're going to have far more, and I can get into the specifics. It has a bunch of magnets, and like then like it can tell like this magnet, and it pushes it like it knows how much to turn it 15 degrees. So like, but if you're going to be using a motor that has like a level of like specific control for relatively cheap, it's going to be a stepper motor. So this one right here, like these, are usually going to have a driver. It's going to have its own chip, and that chip is going to know how to communicate with the board. So right here, you're going to be connecting that, and then you're going to be connecting the Arduino to a board, and then that board is going to be talking to the servo. So I recommend when like doing wiring to start with the like 5 volts in ground. Just always put that to, well, let me get one with a, so start with 5 volts in ground. Always just put that to your board first. Oh, firstly, disconnect your board from any power source before you any.
I was just showing for whoever's like
Yeah.
seeing the screen. I don't know
Yeah.
if they can see it, but right here, G and D, the red wire is connected to the ground.
Yeah. And then this is just personal preference. I just tend to go from left to right.
Just a stepper motor.
Left, like, because on the Arduino, like personal preference, it's gonna be like 5 volt and ground is gonna be right here. And I just kind of follow linearly across the pins, and the walkthroughs will like, oh, well, like from analog to, it goes out to wherever. And I just follow each one along, and I put not caring where they go or what they do, I just put them out where they need to be. And then once I have all of them, like done all of the circular motion, then I'm gonna go back and I look at the pin positions and make sure everything right. Because when I breadboard, like when you're at an angle and you're looking at a breadboard, you are almost certainly, if you're doing more than like 15 or 20, gonna accidentally put one in the wrong row. Like it just happened. And then you spend 20 minutes trying to figure out why you code or what's going wrong. And then you look down and you realize you just had one of the pins in the wrong place. It's gonna happen. It happens to me far more often than I would like to admit. And yeah, so just be a little careful when you're doing it, but the wiring diagrams are going to be very thorough, and all you have to do is follow. If you're trying to make up your own, that's a whole nother ballgame.
What does verify mean?
Okay, so
So I guess, there's a run button, but
Yeah.
once you have your code and, plugged in your Arduino IDE, there's well, I believe there's a test, button, right?
yeah, let me. So here is the verify, and it's going to.
It basically checks syntax and stuff
Yeah.
like that, make sure that the code is properly formatted.
And this, it kicks out saying that if you put this into the Arduino right now, it should work. There's no errors saying, like, there's no issues with the libraries, there's no issues with the like code itself. If it doesn't work, it's a actual like written problem, like your code is wrong somewhere. Just
Then the
because,
code inadvertently makes the Arduino spec.
yeah,
And does it usually, for example, could you make an error on there? What would be the display? Would it tell you where the error is and how you can find it?
yeah,
So like delete one bracket or something.
yeah,
Do we need to run anything to like, because I know that during their presentation, JC showed that like Tinkercad can be used to show how code can be simulated on a virtual board. Do you want to have that as like an additional verification step? Do you want to like?
no, that's not
Is it-
It pretty much does the same thing as from up here. It just compiles it and it's,
Yeah.
for Tinkercad at least, the way it works on there, you're pretty much blocking together the code. So it really can't mess up on there.
Okay.
Once you
Yeah.
actually start writing it though, when you get into the issues.
Yeah, so here's a really common one you're gonna run into. I just deleted a ending off of it, and it's just gonna tell us where it, like, also an important thing is usually when it picks up an error, the error is going to be on the line above it, or it's going to register, but it tells you, like, see error, that the error for it is above it. I just deleted the end off of the first line. Copy error message, literally it just prepares it for you when you go, oh, I don't know where this is from. Just click that and you go Google it. Someone far smarter than any of us has given a walkthrough. And
Where's it say the line? Like, does it say the line number? Or it just says,
this one's not very complex, so it's gonna
analog, right, red, and right. I didn't really see what's needed on there.
I deleted,
Oh, I see it, semicolon.
yeah, I deleted the semicolon off of the first, but the thing is, so like now it'll run, but it's pretty often that it's not going to kick back the code on the, like if you forget a semicolon, it's not going to tell you, it might tell you that it's missing a semicolon, but it'll often IDEs will often kick back an error on the next line. So you
So like if, because it said analog right, red pin right, doesn't work. So that's basically connected to red pin, which you haven't had the semicolon on.
Yeah, and also because there is no semicolon, that line is an ending and it's trying to go.
And it makes the analog right invalid.
Yeah.
Well, I guess like another conceptual thing that I'm struggling with is that with the project that we have, since all this documentation, including like the code for like the board. Could you describe your understanding, like the actual coding task? Is it just getting onto the board? Where's the configuration happening for this?
The configuration for us is, it's gonna be pretty much the same process because we have the code.
Right.
The idea that having everything makes it simple, like putting stuff together, even if you have a walkthrough, you're gonna get code, you're gonna get errors, you're gonna get issues, you're gonna have issues putting it all together. And our intention, like what we have to do is we have to be able to decipher all of that and be able to put it together properly.
Yeah.
So like electrical, we put together, I mean, this is a good example. Like we're about to make a joystick. So like we do this, we make sure, like we like solder this all together to make it so that this joystick's put together. Then computer then make sure the code for it will be working. Then mechanical is gonna design a housing for it. And
As far as the code goes too, they have pretty easy because it's essentially gonna be copy paste.
yeah.
Yeah, that's
Yeah,
what.
and that's why this walkthrough I think is important, because it's gonna be the same process we're following for the Rover. Like all, like instead of having to Google it for us to find a walkthrough, we have the walkthrough. But like these are the issues you're likely gonna run into when you're doing a walkthrough like this.
Another thing I'm pretty sure I saw is they provide comments.
Yeah.
So
Yeah,
it
well-
explains how everything works.
So guy runs all, we can do it for different board.
So we're basically gonna be doing that, but.
Okay,
Just go to Wolfie, check some of the code, make sure we're on the right.
And it'll basically be almost directly connected, right? I need the wires.
Yeah.
where is the attendance sheet at?
So in the Discord, Rover general. Are you gonna have the, oh yeah. So, are you part of the Rover chat? and stuff like that? So go to,
Have you guys done the initial like interest forms and like done and reviews and so forth?
I think so. Well, maybe not they do, yeah. But I would like to, but I don't know where it goes.
Are y'all interested in the robotics stuff? Or was it, because wasn't it joint with IEEE, or was that a different workshop?
I actually had their
so
Oh, okay.
you should be able to see role assignments on there. This is, let me show you what you're supposed to see.
I'm just concerned that.
Basically, like when you see the Rover, you're supposed to see this stuff. Let me check something. Where is? Did we change role assignments? Like, do we not have that on there anymore?
Jonathan went through earlier this week and just like, he cleared out everybody that hadn't done dues and stuff, so if somebody's like, if you want to put down your contact info, just your name and just like a good email, we can get you guys started with the membership process.
And I'll also add you on the information.
Yeah,
Good to go.
that's a good way to get started.
If that was, if they had Discord accounts, I could get to, because I probably.
There's someone else.
Yeah, I mean,
So
if you have to, we can add you, we can add you.
So this is a good, so like most code you're gonna find is gonna have like define a variable, state of the port, rotate a full terrain. It's gonna list out where everything.
Most good code.
Well, if I see it, like, unless I have to, like, if I see code that just does not have comments, I'm just like, unless there is no other option, I am not using it.
Yeah.
Like,
Do you even do maybe something?
Oh, no, just give it, just like if your contact, you wanna put like your line, yes, say it, or picture.
And then, if you don't mind putting your Discord name, right, add you right
Yeah,
after.
did you already?
Yeah.
You did? Okay.
This is the advanced robotic.
And your
Yeah.
name's Maribel?
And then we can-
Are you interested in joining as well, or?
You just kicked it.
Oh,
Yeah. And so,
okay. Super welcome.
yeah, so I mean, this is just kind of all of the issues you're gonna be running into if you're not. And like the thing is, if you wanna do a humidity sensor that senses like for a greenhouse and it senses a range and it kicks out like on a screen that it's too dry, then you go look for a walkthrough for a sensor and you go look for a walkthrough of the LCD screen. TBH, there's gonna be one for exactly that thing.
Yeah.
But when you get more niche, you can still use these pieces to get where you're going. All you're gonna have to really know how to do, like where the really coding legwork is gonna come in, is when you want if statements, when you want a while loop, just actually making the code function how you want, rather than it just being like able to interpret it.
Right.
So, yeah, this like walkthrough is just gonna be able to get you, like if you wanted to go home and you had these pieces and you wanted to get one of these things working, just going through each one of these steps and following these, it's gonna lay out where you're probably gonna run into an issue and the quickest way to solve it. Boom. It's gonna turn like if you were doing this by yourself at home, 5 hour, 6 hour task into a 35, 40-minute task. Like it makes it from A to B, cutting out like where pretty much everybody's always gonna run into an issue and where the most common issue is gonna be from and how to solve them.
Is there a sandbox feature on Arduino or just wanna play with the language? I don't know how you see the exposure, so I don't really.
Yeah, there is actually, there's an example thing, right?
Do you just make like an Arduino account and play around?
We don't even need, yeah, so examples.
There we go.
Yeah.
Basics and everything.
Yeah, no, I mean, it literally like stepper, robot motor, like bridge, Adafruit, like US, like it,
Hey, robot control, there we go.
Yeah. boom.
I see one.
Yeah. Well, I mean, it's pretty much gonna look like this. This is a walkthrough. Like right here, like all of the code I attached is just gonna be really simple. Like, oh, I want to learn how to use a stepper motor. This is the most basic functioning.
Yeah,
Like,
see right there, it says stepper on the bottom even.
yeah. Well, yeah. Let's go look at.
It should be at, like near the bottom.
Yeah, I see it. Why is your mouse so slow?
Yeah, I changed the sensitivity. It was because I was working with these.
That makes sense. So yeah, commented.
Comments are, if you're confused, comments are the first place to go.
Yeah. And so they're going to do most of their comments at the first, but there's going to be a really robust, just back-end ability to pretty much show you everything you're going to need for Arduino. I was just going over like everything. You might not know where to look before you know where to look.
Yeah.
And really, I think for the Rover, we're going to likely be doing this process like an electrical person when we split up the Rover. Like someone's going to be in charge of the like motors, and they can do like they can get to understand the libraries that are going to be controlling those motors. They're going to be able to get to understand the like pieces in the middle. They're going to be able to understand the wiring. And then once you split all those pieces, like each one of these is just going to be how you digest the Rover as a total. Like it's going to have lots of sensors. It's going to have lots of wires moving everywhere. But the thing is, when you break it down into each one of these pieces, it's going to be like a piece of code this big. Like there's only going to be like 3 or 4 lines of setup for each one of these things. Well, some of the things get a decent amount of setup, but like, you're just gonna have to know the library. Like, this is a good way to like at least be able to recognize the library, be able to recognize what kind of setup you're gonna need, and how to be able to call it and get some kind of data out. And any additions to that?
Nothing went over the examples.
Yeah, I guess. Well, let me pull up a. So this is literally the Arduino website. Like, this is documentation created by Arduino to control potentiometers. So all you need for this so hardware required. It's going to use a potentiometer, 3 resistors, some LEDs, and some wiring and a breadboard. It explains the circuit, but I always like pictures better. So, bam. You're gonna.
Do you have the ability to practice with actual components in the lab if you want to?
During open lab sessions would be one of the best times.
That's awesome.
And for stuff like this, that is where Tinkercad, like we've said before, comes in. You could do this whole thing in Tinkercad with relative ease. You're not going to run into a lot of issues you end up running into in person, like, oh, the pin is burnt out, or like it's just not putting through the breadboard in the right place. But like, to get the handle on like these kind of things and just getting the coding running, Tinkercad's going to be good. But to get this running, that walkthrough, like this walkthrough is good. Along with the PowerPoint slides, just the issues you'll likely run into will be good. And then mix color coding, bam. Gonna have the block of code. It's gonna have input, potentiometer should connect to the 5 and ground. And then potentiometer output connected to analog pin 3. Explaining line by line what it's doing. Somewhere it explains why it's doing it. Program variables. And so if this is your, like, let's say we need to use a potentiometer for it. And we need to go out and learn how to do potentiometers. Once you understand it through this code, whatever you need to do, you can likely Frankenstein at least a little bit of this code into whatever you're doing. And
Most of coding is just copy paste.
yep, you just have to know what to copy and what to paste. That's the real trick. I can't imagine how hard it had to be in the 60s where there was nothing done. You're just like,
What about the one where they like?
It wasn't
punch
copy
holes
paste,
and
they
big-
had like cards, they just put
Yeah.
the cards.
Just phone cards?
yeah.
The
But-
script kiddy was in like a little file cabinet.
So, yeah. And then let me also show you this. So under tools, so this is going to be getting the board to function with it in general. So do you have an Arduino?
I got one on.
So with the, so you're always gonna need to select what board you're using. And I'm using the Arduino Mega, it's pretty obvious, but it will always say. And then you're just gonna have to go under tools and select which board you're using. And then this isn't an operand, so it should just tools, processor, port, and then it's going to tell you, well, you can't really quite see it.
Yeah, I don't know why it's being stupid.
Yeah, COM7. So it'll tell you once you go to the port, if you're not having the off-brand board issue, it's just going to pop up like COM7 Arduino Mega. You're going to press that, then you're going to choose what board you're using, and then you can verify. Oh yeah, you can't see the.
You couldn't see the whole thing.
Yeah,
Oh my god.
I had a feeling that was the issue.
Oh, so it wasn't the full screen, it was just that one page?
Yeah, it was just the PowerPoint.
I am sorry about that, but basically, this is what it looks like. We'll also be going over that during the general.
Yeah,
So,
and while it doesn't get too much in detail in the PowerPoint, if you sit down and you want to do this, the PowerPoint is going to walk you through. Like you go to you bring up that Arduino page, like walkthrough, you get the pieces, and then that plus the PowerPoint should be able to make it all the way. There's pretty much no walkthrough or pieces of anything you shouldn't be able to do with working off of that. Once you have your Arduino, and you understand that a few little niche things you can pretty much do anything. It's just pick and play.
I think for me, like, just going through a couple of these workshops, like, I think it's just gonna be a matter of like getting in front of like a console, like working on code and just have that feeling of, oh, this just works.
If you want me to do it like while we're doing drawing, I can just walk you through doing something.
I might take you up on that.
Yeah,
there's also, if you ever just want to individually work on stuff in your own time, just let us officers know on Discord, as long as there's one of us in the lab, let you in. I'll also be there to help you with other questions on anything. So,
yeah, I set this whole thing up and I have all the pieces. If y'all want to do any of them, I can just walk you through it. Like I ran all the code I put on there, and like I know the libraries you need, and I can just show you. But really, I went through the process myself, and I was just like, well, what do I need to do in each step? And I wrote down everything that like you might just not do. Like if someone didn't show me, like you spend 2 hours, or like because walkthroughs don't go, oh, by the way, if you have a knockoff board, like they don't tell you those things. And so I'm tempted just to start walk through things because some of them are just so bad.
How deep are so you want to come here like to member on with you have to be a member or like
For rent amount?
yeah.
Yeah, the rent amount, you have to be a member.
Yeah,
Yeah, I just want to do it. That's right.
Yeah.
Message, maybe come
in the
here.
general chat, just say, I guess, at officers. Yeah, say at officers. I would like to come in at this time to work on this. Is anyone available? And usually someone is.
And you just can come in and pretty much most of everybody that's gonna be here to do this. This is pretty like actually designing your own code. I mean, there's no real reason that you would have to. If I'm gonna use something that I like if I'm gonna use a server or something, there's no reason that you should try to build it from the ground up. Like just include this, like setup, like that is damn near suicidal. Like, yeah, we do it for logic design, we do it for a microcomputer, but like that's so we can understand it. He even said like, you're never gonna do it like that again, unless you're getting really, really, really niche and you're like the PhD person who's like designing the thing, and you like milliseconds count, there's always gonna be pieces of code you can dissect to make what you want. And I highly recommend always starting with that. Otherwise,
Start with an example code.
yeah. And there's gonna be example codes for everything. There's gonna be libraries for it all. And then you just take those pieces and put them in. And this is just how to use the and most common issues.
That's excellent, Ross.
Is there anything you wanted to add before we move on to the joystick, or are we all good?
I think I love it.
Good?
Yeah, I think they have meetings too. I don't know if they're gonna be able to stay.
Yeah, sorry, are y'all gonna have a meeting, or y'all having a meeting right now? I'm sorry for disrupting or anything like that.
Oh, it looks like it's next, so we got. It's 1 minute.
To next week and include it with, in a 3D printing workshop.
So,
So
Yeah.
I mean, do you want to speak tomorrow? Tomorrow's Friday.
I mean, other than usually, obviously, we're all caught up on what we're doing. He also knows that there's most of the general meeting, and we talked about it earlier. I think he's just as bad as the rest of us general meeting.
Are y'all gonna wanna be involved in making a joystick controller, or you're just here for the workshop?
No, yeah, I would.
Okay.
So we're gonna give it a shot for next week.
Yeah, I don't wanna like announce to everybody, you're having a meeting on Friday tomorrow. I would like to incorporate it along with a, probably a 3D printing workshop would be good, because that shouldn't be too hard to cover. Probably take like 30 minutes max. And then we can start going over.
We have what we need. We can use those two printers over there. We don't need to go anywhere else. Okay, so we'll talk to Kai this weekend.
Yeah, I think that's a better idea, just because not only will we have background on Arduino, it'll give time for members to practice on the Arduino if they'd like to. And then we'd also be covering 3D printing, which is what we're gonna be covering in the joystick general meeting, like, you know, we're gonna show the code and we're gonna show the design that we need for the shell. We're already having experience with the Arduino, then we're gonna have experience with 3D printing, so I think it goes together.
Ross, Jonathan, do you guys have like homework that you want us to do between now and next Friday? Is there, do you have access to do you want to share the code with the joystick? Is that something that's explainable?
I can sure take code on this. It's gonna be almost.
This is just generic Arduino.
Yeah, this is the generic.
So-
but, I mean, the Sawppy is gonna be a bit something, but if you want to understand, go in there and like I can't find you on some it's gonna give you the exact style. It's gonna be the same setup. Like, you're not really gonna get that much different code anywhere you go once you get into the same. Yeah.
Just a gear ratio.
So what I'm gonna do is on the Discord, for those of you that will be listening, I am gonna provide in our general chat, well, actually, I'm gonna provide it as a reference. So,
I mean, we don't, I can do that to you, or you're doing it now.
yeah, I was just gonna put up, like, y'all are free to go, I'm just gonna put up the PowerPoint that he just went over. I'm gonna put in the link to our Rover GitHub codes, so y'all can just look over it, just try to understand it. It's commented. Let me show you what I'm talking about in terms of the GitHub codes, at least before I upload it. So Sawppy, GitHub, random. If y'all were to go to it from Google, you would just go straight to the GitHub, click on no, my bad, not docs. Arduino Sawppy. So this is our bread and butter for making the joystick in terms of coding, and then it's also going to provide additional information. So right here, the Joy Drive C++, and then the Little Soul, that's for the motors. C++ are going to be included, And as you can see, in the comments, it provides exactly what this code is meant for. I don't know if it provides additional comments. It doesn't seem like it, but yeah. See, there's some comments here. Let me know if y'all have any questions on that. Again, we're gonna be going over it together when we're trying to build the thing and program it. So don't worry about it too much. I'm gonna provide the link for this, the presentation, and should be it. So yeah, and yeah, no problem. That being said, y'all have a good one. Thank you for coming. It's really nice having you here. Yeah, if you have any questions, let me know. You can hit me up on my Discord name is Alex Tinker. So just let me know. Yeah, y'all have a good one. So let's see here. I'm gonna stop sharing. And then thank you all for watching this video, for whoever was able to catch up on all this stuff. Bye-bye.